Good evening, students. How are you doing? So this is an example in Unit 5 of the Chemical Engineering Thermodynamics. So let's look at this question together. Air enters into an evacuated vessel from the atmosphere when the valve of the vessel is open. The atmospheric pressure is 10 raised to power 5 Newton per meter square, and 1.5 meter cube of air at atmospheric condition enters into the vessel. Calculate the work done by the air. So we are asked to determine the work done by this air. So our system is the air. We have to take note of that. And as usual, this is our common practice. We need to extract all the data that we have from the question. So the two prominent data that we can see from this question are pressure, which is 10 raised to power 5 Newton per meter square. And we have the initial volume, which is V1, and that is 1.5 meter cube of air. So we should know that once this 1.5 meter cube enters into the vessels, we are going to have no air left in the system. It means our V2 will be 0. So that is how V2 is equals to 0 meter cube here. That's one. So for us to be able to proceed, we need to make some assumption, and one of the assumption is that we are going to have constant pressure, or we have constant pressure. And the work is going to be assumed to be a reversible work. If these two assumptions hold, then our W will be given by this expression. And since we have constant volume, we can actually bring out P, and we keep only dV within the integral, because P is constant. So by so doing, it means what we have is W is equals to P integral V1 V2 dV, right? So if we integrate this one, we're gonna have V1 then V2, and a further simplification means V2 minus V1. So if we substitute for the values that we have P is 10 raised to power 5, and we have V2 to be 0 minus V1 is 1.5. So what do we do here? We're going to have minus 150, and this will be joule. It's a very big value, so we can make it as 150 kilojoule. This is our final answer. Please take notes. You need to be consistent in your unit. You need to be consistent in your unit. For us to get joule as the unit of this calculation, our pressure must be in Newton per meter square, and our volume must be in meter cube. These two are SI units. Okay, so in case if you are given pressure in bar, in atmosphere, in kilopascal, just make sure you convert to SI unit, which is Newton per meter square. Thank you, and see you in the next video. Bye-bye.